So, a very good evening to everyone. Week 7 is been already over, and we are going to solve few questions based on the week 7 content. So that the assignment questions we will be able to solve them very easily. In the process, if you have any doubt while this particular discussion, please feel free to ask me. You can comment and you can also unmute yourself and interact with me. Okay, yeah. So let's get started. The topic which are covered in this particular week. The topic which are covered in this particular weeks are, as mentioned, there are the 10-point groups and 5 lattice we have discussed. Along with that, the 17 plane group. So the combination of 10-point groups and okay, I forget to share my screen. Uh, just a minute. Yeah, no, not this. Yeah. So in this particular week, the Professor Rajesh Shah, discusses the following contents, which are the 10-point group, 5 lattice points, and we have discussed about the plane group also. There were a total of 17 plane group, which was generated from the combination of the 5 lattice and 10 point groups. So point groups and the lattice are the one which are giving us 17 plane group. Okay, so let's move ahead and solve few questions based on these particular topics. It seems like that we not covered a lot of topic this week, but no, it's not the case. This particular syllabus itself is a very huge, and the content which we are discussing in this particular week, the last week, was quite tough, so that one need to watch the video multiple times. Okay, let's start with this particular question number one. Question number one says, what information can one extract from the following plain group notation? इशू हो रहा है, कट हो रहा है बार बार, पता नहीं क्या, कुछ कनेक्ट कुछ डिस्कनेक्ट हो रहा है मल्टीपल टाइम्स. डजेंट मैटर क्योंकि कोई ज्वाइन नहीं करता है. मैं अपलोड करता हूँ उसके बाद लोग देखते हैं रिकॉर्डेड वीडियो. तो 30-30 मिनट वाला नेट चला के 2 बार में नहीं कर सकते. नहीं, दिक्कत नेट का नहीं है, दिक्कत कोई कनेक्शंस का है. कुछ कनेक्ट हो रहा है, डिस्कनेक्ट हो रहा है. मुझे लग रहा है यही बार बार वायर का कनेक्शंस का इशू. जब तुझे किसी की सुननी नहीं है तो ये वायर कनेक्ट कर क्यों रहा है? तुझे सिर्फ बोल के अपनी तो आवाज देनी है ना. हाँ, तो मैं इसको निकाल देता हूँ. Yeah. So let's get started with the question number one. What question number one is telling us? We have to write the information. What information can one extract from the following plane group notation? So we have the total of 4 plane group in front of us, and we need to know, like from each of them, what information they are representing. Like the P. Let's talk about the first one, P4MG. What does this mean? What are the information that I am getting from this particular plane group? What are the information that I can extract just by seeing the this particular notation in front of me? That is something we need to discuss. So to understand that, we should also know the waving direction for the plane groups. Okay. So if we talk about the plane groups, let us say we are having the oblique, we have rectangular lattice, we have centered rectangular, and then we have square, and then we have the hexagonal. So there are the few viewing direction that is associated with the this particular lattice. There are the two first and second viewing direction. The first viewing direction, the oblique, is both of them are none because the way they are, they don't have any symmetry associated with them. So any direction is not a like you can take any of the direction, and that direction won't be any unique. It won't represent any uniqueness. While for the rectangular, there is a direction that is along the A and along the B. So if I draw a rectangular lattice, considering this direction to be the x, to be the A, and this direction to be the B. So my this direction, the first direction is A, and second direction is B. We'll see what we are saying by this A, B, and all those things. For the center rectangular, again, this is again A and B. For the square, the direction is along the A, and another direction is along the 1, 1, 0. That is along this. If I consider this to be the square, keeping both of them equal, right? And for the hexagonal, it is A and 1, 1 bar 0. Now one can ask that, okay, we are sticking with the plane group and still we are writing the three notation, three million notation, which won't be the case. But for the space group, like to generalize the thing, international table always take into account the third direction and make it to be the zero since in the c axis there is nothing. So one can also write them as a 1, 1 and 1, 1 bar. So these are the viewing direction which we are discussing about. Let's see what we want to know from these viewing directions. Where we are going to use them. Let's start with the first one, P4MJ. P should be small. This is the one which we are looking for. In any of the space plane group notation, the first one is telling about the type of the lattice, whether it's primitive or centered. Okay. The second is always the fold of rotation. And this remaining two part, among them, first part is a symmetry which is along the first viewing direction. And the second one is a symmetry, is representing the symmetry along the second viewing direction. Okay, so since we are having the mirror in the second place, what we can say there is a mirror which is perpendicular to this particular direction. So uh, if the symmetry is mirror, so what uniqueness we can define that particular mirror, that will be defined by the one of the directions. So we can say along the first viewing direction it will be perpendicular. Now understanding this thing that first one is representing for the centering part, whether is a primitive or the centered rectangular or centered, that is. Second is always tell about the rotation, then which is followed by the first viewing direction and the second viewing direction, the symmetry which is along the first viewing direction and the second viewing direction. Now let's thoroughly understand this particular case, P4MG. We know there is a fourfold of rotation and which is possible only in the case of a square lattice, right? So we got to know, uh, see, among these five lattice, which we are having. Hexagonal cannot have the fourfold. Rectangular is not having the fourfold, whether it's centered or not centered. It doesn't matter. Oblique is not having the fourfold. The square is the one which is having the fourfold. And what we know that the viewing direction of the square is along the 1 1 and a 1, sorry, A and 1 1. Okay, so let's draw one square. I might distorted the shape a little bit, but we can consider this that it is a square. So considering this to be the square, this is a direction which which we will follow from the international table. This is a B direction, let us say. So now, what this particular information is telling that since we got to know, okay, from the fold of rotation, we got to know, okay, this is a something like square lattice. From P, we got to know that this is a primitive. What additional information this lattice is having the fourfold along with itself. This four is telling. So this is a fourfold. This is also a fourfold, and so on and so forth. So all the lattice point of this particular primitive will contain fourfold. We are done with this particular part. Now there is a mirror which is along the first point direction. First point direction is, since both of them are same, so quantity wise, whether it's A or B, both are same only. Okay. So there won't be any partiality between A and B. So there is a mirror which is perpendicular to the first point direction. I'm telling that okay, I'm a mirror, but at what position I am? That's the first point direction. First point direction is A. So we got to know this is a mirror because this is the one which is perpendicular to the first point direction. This is the point direction. Okay. Since there is no partiality between A and B here, so there is also be a mirror over here. And we know a set of parallel mirror will also create a mirror at the half the lattice translation. I mean, we can add a lot of symmetry to it. So this is what we have discussed about the first point direction. This is M. What is G? G is a glide. And we know glide is made up of two parts. It's a mirror followed by the translation. But the translation of by what? Translation by the amount of half. Half of what? Half of viewing direction. The translation is a half of viewing direction. So if my viewing direction is something like, let us say A, so my translation will be A by 2. If my viewing direction is 110, my translation will be half of 110, this particular direction. Okay, so what we got to know, we know that this is a second viewing direction is along this because 110 was our second viewing direction in this case of square. So we can say that this is our second viewing direction. So perpendicular to this particular viewing direction, there is a glide. Why we are saying perpendicular? Because glide consists of the mirror, and mirror should be perpendicular to something. Okay, and we will translate by 1 by 2. So along this particular direction, there is a mirror which is at the 1 by 2. Sorry, there is a mirror which is a part of the glide, and it will translate the particular point by the amount of translation vector 1 by 2. And that's what this particular entire thing is giving the information to us. This is a way to extract the information from a given plane group. One more thing we need to be noted. This is a small p. A small p is there is a difference between small p and capital P. We use small p in the case of plane group, while capital P for the case of this space group. And with that, we have covered the first part of this particular question. So on and so forth. Knowing this particular viewing direction, one can extract the information from this particular entire list of questions. Let's do one more. P6 mm. Okay, let's try this. Now, second question is P6 mm. Sorry, third part I'm taking. Again, I made a mistake. I should write small p since we are discussing about the plane group. Uh, One might be wondering why not we should also try B. See, it's very easy. Okay, this one it means that there is if the symmetry is 1 1, it means that it doesn't have that any of the symmetry elements in that particular direction other than trivial symmetry, which is 1/4 of rotation. Okay, so B is very easy to solve. One can easily extract the information from it. Let's also solve the C part. It is also very easy. It's not that difficult. So what we are seeing over here that there is a sixfold, and we know in which of the Bravais lattice, sorry, in which of this particular five lattice which we have seen in the case of 2D lattice having the sixfold, it is a hexagonal primitive, and itself this we also know that this is primitive. So let's draw one hexagonal unit cell. I'm not taking an exact measure of the angle right now, but we can imagine that okay, yeah, this is 120 degree itself. And we just got to know the two positions what they are representing. The viewing direction in the hexagonal case is along the A, that is along one of the axes, and 1 bar 0. We don't need to worry about that 0. We can also write them as 1 bar. So in the x direction we have to go by one amount, in the y direction negative by -1. Okay, so this direction is nothing but this particular direction. This particular direction is our second viewing direction, and let's say this is our first viewing direction. So primitive, we got information that okay, this is primitive in nature. Sixfold is telling something that okay, to associate with each of the lattice point, we have the sixfold of symmetry. And with that, we can say that okay, this part is also over. We got to know information about this. Again, this sixfold will add more of the symmetry elements in this particular, but let's only stick with the information which we are getting right now from this. Now, the second place, this is the first viewing direction. So perpendicular to the first viewing direction, there is a mirror. So we got to know that okay, there is a mirror perpendicular to this. And there will also be a mirror perpendicular to the second viewing direction. Okay, so something like this, it will go. And with that, that's how we can generate the extract the information from the plane group, the notation of the plane group. Okay. So with that, our question number one has been solved. Question number D, one can do by their own because it's not that very difficult. it is difficult, but the way we have studied, like the understanding of the viewing direction, once someone know that any of the question, you can try for all the 17 plane group. Just write their names and one below the another, and without seeing the international table, one can write the answers. Okay, so with that, question number one is over. Let's move to the next question. Question number two. This time, things are quite opposite. Right now, we need to find the plane group. The the following diagram is a symmetry element diagram. Okay, so it's highlighted over here that it's a symmetry element diagram. So there is a fourfold we can see, and we sorry, our question is we have to write the plane group. We can see there is a fourfold, and right now, just few minutes before, we have seen that fourfold is present in the case of 2D lattice. It is only present in the case of square, and the square as only primitive. So the way we write that it to be the P primitive tetragonal. It doesn't have the centering, but there is a centering. A center also is having the fourfold. So this fold is by default generated fourfold. Okay, how we are going to find the plane group? We'll stick with our same fundamentals. Okay, yeah. So we'll find the viewing direction and we'll see what are the elements, what are the symmetry which is present in that particular viewing direction. What information we have extracted till now that this particular uh, symmetry element diagram is of the square lattice, right? And we know for the square, the viewing directions, the first thing which we can write for each rotation that it will be the fourfold rotation at the origin, which is also given over here. It will be primitive, first of all, because the square lattice is primitive in nature. Now there are the two remaining places are there which we need to fill. And once we fill that, our answers will be completed. Our this question will be completed. So the first place will be the symmetry which is corresponding to the first viewing direction, and the second place will be the symmetry which is corresponding to the second viewing direction. And we know in the square case, what are the first viewing direction? First viewing direction is along the A or along the B, one can say, because A and B both are same. For the second, what we know, for the second viewing direction, we know that it will be along the 1 1 direction. Okay, so let's mark them. Let's mark these directions. So this will be along this. First viewing direction is along this. Second viewing direction is going along this. Just for the information, we never draw. We don't draw. It is not recommended to draw these things in the symmetry element diagram. But just for the sake of our getting the answers, and we are just imposing. We are extracting the information from the particular image, from this particular symmetry element diagram. Now, what we can see, there are the solid lines. These are the solid lines. They represent the mirror. They are nothing but they are the mirrors. This mirror is perpendicular to the one of the wave direction. We can see 100. So what we got to know, that perpendicular to the first wave direction there is a mirror. So we can write the mirror and do it. So this is what our first position is holding. First position is holding the symmetry of the mirror. What about the second viewing direction? If we go about this particular second viewing direction, we can see that again there is a solid lines. And the symmetry element diagram, the solid lines are mirror. These are the fourfold. These are the twofold. You can see there are the few dotted lines also present. These are the glide lines. These are the glide plane. And the solid lines are the mirror. So what we can say in the second viewing direction, along the second viewing direction, perpendicular to the second viewing direction also there is a mirror. And so the mirror is again holding this particular place. And with that, we got the information that this particular plane group is nothing but P4mm. We will again visit this particular P4mm plane group. Okay. So, so knowing the symmetry element diagram, how one can extract the, one can know the what plane group it is belonging to. This is a procedure. Start with the fold of rotation it is having. Try to find okay whether it is square or hexagonal or rectangular, center rectangular or what it is, and so on and so forth. One can start using the previously accumulated data to find the what will come in the further cases. For example, here we started with the square, okay, and then we think okay what viewing direction square is having, and when then we went to that particular direction, we see that okay what symmetry elements are along those directions or perpendicular to those directions, and we wrote them. And this is how our question number 2 has been done. Okay, multiple things we can do over here. Let's preserve it for the end. If we have time, we will visit that. Let's move to the question number. How should we do it? Okay, let's do it. Uh, let's draw its general position diagram. Considering this particular thing, considering this particular plane group which we have obtained P4mm. Let's draw its general position diagram. For that, we'll make one square first because it is belonging to the square lattice. Okay, I will just divide them. This is general position diagram, so all the lines one shouldn't consider them okay they are the mirror or what. Only in the symmetry element diagram, one should consider the line to be the mirror, dotted lines to be the glide. Okay, so here I'm just dividing the my figure for the reference cases. Okay, let's start with the first point. This is our point. First point. We know that here we have the fourfold of rotation associated with this particular point. We can see this fourfold. What this will do? This will rotate it. Okay, this is going to rotate. This is let's make it just for our convenient. I am drawing this. Okay, rotate it by 90 degree. So where it will come? It will come over here after rotating by 90 degree. Again rotate it. I will get it to this particular point. And again rotate. We'll get to this particular point. Okay, it's looking non-symmetric way, but yeah. Okay, so this way, let's draw it in a better manner. Okay, so let's move to the question number 3. What question number 3 is about? Again, the same thing. Like the symmetry element diagram is given to us, and we need to find the plane group. Okay, so here are the two-fold rotation. We can see that there are the two-fold rotation is available to us. Let's try to recall that which of the lattices, 2D lattice, was having the two-fold. Two-fold is contained by the rectangular, center rectangular, and there is one more, square, square lattice. By any way, this is not looking like a square lattice. The dimensions here and here, they are different. So we can cross it. For the center rectangular, for the rectangular, there shouldn't be any centering over here. Okay, so we can see that these are the fourfold. If I talk about this, is this point we are talking about. Let us say a centering is there. Okay, so we can say that okay, yeah, we can neglect this rectangular part and we can go with the center rectangular. This is not a quite right way to do it, but this is giving some way to get the informations. Okay, so let's see that okay, whether we are right for choosing the center rectangular or not. For the case of rectangle, what we know is this is a the viewing direction for the rectangular is A and B. So one viewing direction is this, and another viewing direction is this. Considering this to be the centering, C we can write starting with the C. The fold of rotation associated with each of them is 2. The remaining two place we need to fill. So the first place we can see that okay, this is the solid lines. This all are the solid lines, and solid line represent the mirror. So we can say that okay, perpendicular to this particular viewing direction. First one, there is a mirror. Also perpendicular to the second viewing direction, there is a mirror. So this is C2 mm. So now let's consider C2 mm and see whether we are able to generate this or not. If not, then our assumption of considering it to be the centering, center rectangular, will be incorrect. C2 mm. Consider the lattice points, this, and this to be the center point. Okay, so associated with each of the point, we are having the twofold. Okay. Also, we can see there is a along with twofold there is a mirror. Mirror is along the second viewing direction. So perpendicular to first viewing direction. This is M. So we can say that this will be the mirror. Each lattice point will have the equality in the case of space group and the plane group. So all of them will have this particular lines. Also, one can also say that okay, since we are having this two mirror set of mirror at the half of the lattice transition there will be a mirror. Second viewing direction is also there is a mirror. Okay, so let's draw the mirror again over here. Okay. So they all are the one set of mirror associated with each of the lattice point. So now these two set of mirror will generate. Okay, let's talk about the rotation first. These two rotation, at the half of them there will be another rotation which will be generated. Again, among these there will be the half, at the half the distance. A rotation, twofold rotation will be created. Okay, now at half of them, considering this to be the centering, and this is the point, half of them at half the distance, a twofold will be created. A twofold will be created. Okay, and so along this also. And with that we can see that, yeah, okay, yeah, we have covered most of the part. And yeah, this is representing the this particular symmetry elements. Okay, so with that our question number 3 is over. Now let's move to the next question, question number 4. We have to construct the plane group P2MM. So what we'll do is, uh, we'll generate its symmetry element diagram P2MM. Okay, it is primitive, it is twofold. Okay, so let's make a primitive which is having the twofold and mirror, two mirrors. We know that this is happened only in the case of orthogonal, rectangular one. Okay, so yeah, so this is a twofold. At origin we are having the twofold. Oh my god, I'm just trying the pages. Okay, at half the lattice translation, this twofold will generate again another twofold. This twofold will generate another twofold again. Now this twofold will generate another twofold at half the lattice translation. At half the translation along the particular direction. Considering this, there is a mirror also. Mirror is perpendicular to the first point direction. Okay, here. Let's make a mirror with a black. So this was our first point direction. Perpendicular to that, we have the mirror. And also along the perpendicular to the second viewing direction, we have the mirror. So this is our second one. So perpendicular to it, there will be a mirror. And again, we know that two parallel mirror of same set will create another mirror at half the distance between them, exactly at the center. So yeah, this will be another way. This will be another mirror, and one more for this vertical ones. This will be another mirror, and this is how we can construct a particular plane group P2MM. Okay. So we can see it is having the mirror at the center, rotation, twofold rotation. See, one more thing. This two mirror intersection will itself will create a mirror. Sorry, twofold, and this was also creating. So all of them are tra- the translation is in such a way that it is superimposing one symmetry or elements over the another. With that, question number 4 is done. Let's move to the next question, question number 5. So construct PM plane group and also write its symmetry unit, symmetry operation, generator selected, and multiplicity Wyckoff positions. Okay, these are the things which we need to do. We'll go one by one. First, we will construct the PM. M is a mirror, small p, small m. P is telling that okay, it is a primitive. M is telling that okay, there is a mirror. So since a mirror is there, we can draw it. Let's start with the one of the point of the primitive. We are right now we are drawing the general position diagram. Okay, so let me make one. See, there is a mirror. Since there is a mirror, it will lead to rectangular. Okay. For example, let us say this is our lattice points. One of the lattice point I have kept. Now, perpendicular to it, one can say that okay, there is a no twofold. There is no rotation is written over here. There is only PM is written, but in all the cases we were seeing the P2 mm, like there is always a rotation and followed by the two mirror and or two glides or any of them. Since it is not written, it means that it has the one fold of rotation. Okay, so this particular lattice point, if I'm drawing, it won't be having any fold of rotation 2, 3, 4, or 6. It is having the trivial, that is 1. So let's consider, with respect to this particular lattice point, let us consider one of the position. We are placing our motive over here. So now what it will do? There is a mirror perpendicular to the one of the viewing direction. Let us say we can choose anything. Let us say I am choosing this to be the viewing direction right now. I don't know. So perpendicular to this, there is a mirror. So what this will do, that is that there is a mirror. Uh, this is a mirror. What this is going to do? This will just reflect it and change its handedness, right? And this is how it is. So we can go for, since this is a plane group, so translation will always follow. We can translate this point. We can translate this element also, which we just draw. We can reflect it. Same in the this direction also. The thing which we have generated, it will repeat. Now we can join all this reference point and we can say okay, yeah, effectively this is how we have generated the things. This is a mirror and these are the general position diagram. It's okay. So effectively we can see there are the only 2 points which is confined to our cell. What will be its asymmetric unit? Like asymmetric unit will be, since we can repeat this entire thing just by the reflecting it, we can translate them by 1 by 2. We can see that okay, this entire thing will be my asymmetric unit. That is in the x, it will be less than 1 by 2, but y will be less than 1. So this entire region will be our asymmetric unit. What are the symmetry operation we can write onto this? So let's write the symmetry operations. One is a one fold, which will always generate this particular first point. First point is created by the one fold. How this will be created? This will be created by the mirror. Okay. So the second will be mirror. Now, what is the position of that particular mirror? That mirror is lying in such a way that all the, if I consider this first mirror only, here x coordinate is 0, but y can be anything. So 0 and y is changing. So this is representing the one of the plane. Okay, yeah, 0 y is a plane, and that's how we can write its symmetry operation. So these are the two symmetry operations. Let me make them in the brackets. Okay. Now let's write the generator selected. How we can generate this entire thing? So the first will always be like the one. One fold will always count in the general selected. Second is what else the element which we can produce. That is a mirror. From the mirror only we can produce this particular thing. Right? So there is a mirror also. Mirror at 0 and y. Okay. And that's all. We have for the third part generator selected is over. Now for the multiplicity, Wyckoff position and side symmetry. So positions are the thing which we need to write. Okay. Multiplicity, Wyckoff position, or Wyckoff later, let us say, and side symmetry. And let's also write its coordinate. Okay. So we'll start with the placing the things at the. See, we are having in this particular. If we only consider this particular cell, this particular fraction of our entire plane group, what we can see, it is consisting of the mirror, which is at the x0, and y can be anything. And also there is a mirror x half, and y can be anything. Okay. So let's start with the first one, where we are placing our point over here. So this is our first point. So let us say how many point we will generate if we place our point over here. Effectively, to this particular cell, this is contributing by the amount of 1 by 4. We translated it. This point again, it will correspond to the 1 by 4. 1 by 4 it will contribute. This point we have generated, it will also contribute to the 1 by 4 and again 1 by 4. So applying this mirror, we will generate from here to here and from here to here. These two both were generated by the translation, and these points are generated by the mirror. But effectively they are contributing to only one, so multiplicity will be 1 in this case. And Wyckoff letter will be start with the A. What is side symmetry? What symmetry does this is having? This particular point is having what? So it is having this particular, say, what we can say that this entire thing is generated by the mirror. There is no one fold over here. So we write now P4 something like this space group. So you have to write this part onto the side symmetry. There is a no one fold of rotation, empty. There is a mirror. Yeah, there is a mirror. But what about us? Is there any other mirror along with that? No, there is no mirror. So we can write it like this. Okay. But what is the position of this particular mirror? This it is at the 0. and y. X is 0, y is y coordinate can be anything. We shouldn't write them in the bracket, sorry. Now, we have placed our point to this particular symmetry. Now let's go to the next symmetry one, which is this one. Let's place our point over here on any of this particular, anywhere over here. So what it will do? Again, if we consider this point, effectively if we again draw the same entire thing, considering one of the point over here and applying all the symmetry, again the overall points will be 1. Multiplicity will be 1. The effectively it will contribute only 1 to it. Wyckoff, later we can write B. What is the side symmetry? It is again having the same side symmetry. Point M, point M dot, dot M dot. But this time coordinate is changed. It is 1 by 2. X is 1 by 2 and Y can be anything. Now we don't have any symmetry left with us. Now we have to place our point at the general position, not at the any of the symmetry element point, not at the any of the symmetry elements. We have to place our point at the general positions. Let us say this is our general position we have, and which we have already did. Effectively, it is producing 2. So general position is producing overall 2 effective elements. So the multiplicity will be 2. Wyckoff letter A, B is over C. What is the side symmetry? It's not having any side symmetry. So what we can write? 1 is always a trivial side symmetry which is available, so we can write 1. What are the coordinates that has been produced? The coordinate which will be produced will be x, y, which is this one, and next will be this one, that is x is changing. It's because the mirror is perpendicular to the x, so x is changing, so x bar, and y will remain same. It won't be affected by the mirror because mirror is along the y itself. And that's how we have completed this entire thing. So the multiplicity, Wyckoff later, and side symmetry we have completed. This is the question number 5. One can do this for the, like, let us say P4 something like this, and it will be very complicated, but I won't say complicated, but it will be a little bit of more work will be required, but it can be done. Now let's go to the question number 6. So the pattern is given to us, some pattern is given to us, and we want to know which of the plane group this particular pattern is corresponding to. What I can see, let's focus on this particular orange color hexagon. This point. They are forming the six-fold symmetry. If I rotate about this particular point, this entire pattern will be rotated. This triangular will also rotate by 60 degree over here, then it will again rotate, Also the dots, this black circles, they will rotate. This flower type pattern is also having the six-fold symmetry, so it will rotate. Okay, yeah, so okay, we got to know that okay, it is having the six-fold symmetry. What else? Let us assuming that it is having the six-fold for a time being. Let's draw one unit cell. So this is a hexagon, and we know what are the things which we need to put over here. These are the things which we want to know. So do I write primitive? Hexagon will always be primitive, I think. Yeah, it is primitive. So we can write the primitive over here, small p. But what about the 2 points? It should be, this is a should be the symmetry which is along the first and symmetry along the second. So let's just consider this to be the first and this will be the our symmetry. This will be the second viewing direction. This is the first viewing direction. So we can see there is nothing, like there is no mirror which can reflect it. There is no mirror perpendicular to the first viewing direction. If one is telling that okay, there is a mirror perpendicular to the second viewing direction, which is this, then no, again this is not the case because the triangle will not be reflected. Okay, and also things this thing also will not be reflected. So we can say that okay, there is nothing. So one will always be there, one fold along each of the direction. So this is P 6 1 1. We can ignore this ones and we can write them as P 6. And with that, question number 6 is over. It was very easy. So all you need to do is identify the lattice points, identify what fold they are having, and see if considering the sum of the viewing direction, first and second viewing direction, what are the symmetry elements they are holding. And with that, question number 6 is over. Let's finish our today's session with this one of the easy questions. Okay. So here we have to do match the following. We have to match Bravell lattice with one of its Bravell lattice point group, plane group, space group. How do we represent Bravell lattice? Let us say square is there. I should write 2D Bravell lattice. 2D lattice. So let us say we are talking about the square. It will be represented by the tetragonal small t and p. Now the base of the tetragonal is square in nature, right? That's why we are writing that tetragonal t. So we know that this is not the P4 is not the 2D lattice. It is one of the symmetry will be capital P1. Okay, this is again not because capital we don't use in the case of the 2D. OP, small o is small p. What is small o? O small o is representing the it is orthorhombic. So it is rectangular. For rectangular we use the small. And there is small p also, which is representing okay this is primitive rectangular. This is non-centered rectangular. So we can match this. This is one of the varieties. What about the point group? Second one. So point group we can say that this will be this is space group, this is space group, this is already matched and sorry this is space group and this is plane group. This is the one which is a P4 it is representing the point group. So we can match them. What about the plane group? So among this P1, capital P1, small p1. Small p we use for the case of the plane group. So the plane group will be matched with the P1. And the space group will be matched with the capital P1. Okay. And that's how we have solved the question number 7. Now, let's go back. So, before we end our session, let's discuss the thing which we wanted to discuss. The question number 2. So for this, let's draw a general position diagram. Our aim is to draw the general position diagram. We'll take the blank page. Let me take one of the blank page. Yeah, I got it. P4mm. This is our the plane group. And for this, we need to draw the general position diagram. See this 4mm. This is a point group, right? So let's draw its point group first. So that we get to know that what each of the point is having. Now since this is 4, I will divide in the 4 parts. Let's start with one of the point, this particular point. And the mirror is, they are along one of the viewing direction. Let us say this is our x, this is our y. So this is a mirror. We can say, okay, this is a mirror. This will be the mirror. First, apply the fourfold. We will generate this particular point, this, and this. Now let's make the mirror of them. This is circle. This is be circled as. This will be reflected over here. I think I made a mistake. It should be this point will come over here, not over here, not over here. Okay, it will come over here, and this point will be reflected over here. Handedness will change. This will reflected over here. Handedness will change. This will reflected over here, and this will change. Okay. Now if we consider the p, that this entire thing will be repeated. Okay. So let's draw. Let's make a rectangle. Sorry. Let's make a square. I'm drawing in very rough way right now. Still, it's okay. Let's divide them in the 4 part. So this was our initial point. Considering in the same manner, we can consider this to be our one of the point. And what we will get? Let's say initial point is this. We'll get O dash. We'll get over here. Let's make entire thing over here. This and O dash. Here it will be hollow dash. Again here it will be. So we just put the entire thing over here. Same will go for the other points also. Okay, one can do that. It will be very, it won't look very good. I'm also not good in drawing also. Okay. So we can see there are these are the thing which is being generated. Effectively, if I draw for the another points also, we will generate this to correspond to this, right, inside of them. Correspondingly, for the another points, more will come. So effectively, there will be the 8 points which will be inside. Okay, better I draw it. So now inside this, we can see that there are the 4 points we have generated. So effectively, like 4 pair, that is a overall 8. Okay, and that's how one can generate this. What about if we write the symmetry elements, like how we can generate all the points? So starting with this point, how we generated the, let's say how we generated this particular point, or let's start with this particular point itself. How we can generate this particular point from that point itself? That can be done by the one fold of rotation, right? Another point, this, it will be generated by the four-fold of rotation. This point will be generated by the effectively two-fold of rotation, and then this point will be generated by the 4 in the reverse direction. Okay, and what about the other? This will be generated by the mirrors, right? But the mirror is having some position. So if I want to generate this particular point, it will be generated by this particular mirror, and this mirror is perpendicular to something. This mirror is perpendicular to the y, that is mirror along the, let's say this is y, that is O1. This will be the 1O. So this particular mirror is represented by the O1, that is mirror is perpendicular to the O1 direction. So we can generate this. Also we can generate this from this particular point using this O1. Now we can generate this point also by taking this particular mirror which is perpendicular to the x-axis, M1O. So this point is also O. We have generated it. So we are writing all the symmetries. So about this also, this is also a mirror. About this we can mirror it, and from here we'll generate this particular point. So this direction is nothing but the 1 bar 1. So mirror along the 1 bar. And for this to be generate, for us to generate this particular point, we have to just take a mirror along this. So mirror, which is 1 bar. And this is what has been used in the, while writing the symmetry operations in this plane group. Okay, so instead of x 1 bar 1, we write x bar y, x bar x. If both are same, x bar x. Okay, here x bar. Here it will write mx. Y will be 0. So at the position of the y, will write 0. So in this way, one can do it. So 1, 4, 2. So entirely total we generated a point effectively, and there are the 8 symmetry operations corresponding to each of the 8 points. And that's how we have completed this particular dot solving sessions. Okay, you can always comment back in the videos and ask question on the dot forum, so that if there is any doubt remaining, we can discuss those. So please solve that assignments questions, and with the considering the amount of question that we have discussed today, it will be quite easy for us to solve the assignment questions. Okay, so with that we can end this particular session, and we'll meet again in the next week.